Today we'll be working on lesson 3.9 quadratic regression. You will need 3 papers to pick from the front, and one of them is going to be this paper which says 3.9 quadratic regression. The second paper is going to be the calculator steps, which is also going to be glued into your notebook. However, the third one is a practice sheet that's due on Monday. Remember that you have to watch the video in class. If for some reason you were not able to finish it in class, you have to finish it at home and come on Monday with your questions. So I haven't glued this with my first, second, and third period. So for this paper, you have to fold it as a hamburger style and glue it to the right side of your notebook. As for the calculator steps, you have to tape the top of it to the left side of your notebook so you can lift it up and see the back of the paper. Now my notebook is in the front of the room. Please somebody demonstrate the notebook so you have a good idea of how it should be done. Now take 2 minutes to do that. You can pause the video as you're doing that. Now, in order to follow along with this video, you need the following. First of all, get the supply box. You'll be using the rulers from the supply box. Make sure that you have at least 2 for each group. I do have an extra supply box in the room, so you may need to get some of extra rulers from that box. You'll also need your calculator, so go grab one. And each group should have a bag of beans. Okay? So also pause the video and get yourself ready. Now in this video, we're given a certain scenario. We're given a circle, and we're asked to measure the diameter of that circle. So let's look at the circles that we have. As you can see, we have different sizes, and we're supposed to find or measure the diameter for each circle, record that in the table, and then fill each circle with 1 layer of beans, and count these beans and record the number of beans in the table as well. Then once we gather the data, we have to look at the data that we gathered, plot that on a scatter plot on the coordinate plane and create a scatter plot, then decide what type of graph it gives us. Does it give us a linear? Does it give us a quadratic shape? So we have to discuss that. So that's the whole concept. And basically to decide what type of shape it gives us from the graph and how we can tell whether it's linear or quadratic from the calculator. So this is the whole objective of this worksheet, okay? So get yourself ready, and we're going to start on number 1, okay, which is to measure the diameter in centimeters for each circle and record the data in the table. So remember, let's get this our rulers, and as you can see, what is the diameter basically? It's a chord that goes through the center of the circle. So as you can see, the centers are not given to you. So mark the center to be basically somewhere in the center of the circle. And the diameter is basically the chord that goes through the center, cutting the circle in half. So use the ruler and measure that. Do that for every single circle. So go ahead, pause the video and take 2 minutes to do that. Measure the diameter of every single circle. Now I do hope that you tried on your own, and the data that I gathered is going to be 1 centimeter for the first circle, 3, 4.5, 6, and 9.2. So if your answers are close to mine, don't erase them. So let's move on to step number 2, which is basically to layer or fill the circle with 1 layer of beans. So I'm going to show you what I did. So this is a picture of the layer of beans I did. As you can see, I used a different type of beans, and that's why it took me forever to count these beans. So I got you a bigger size. So go ahead, pause the video, and fill the circle with 1 layer of the beans that you have, count these beans, and record the data in your table. Now, as you can see, for circle number 1, I have 1, 2, 3, 4, 5 beans, and I move to circle 2 and so on. So go ahead, pause the video and do that. Okay, now for me, remember I use different type of beans, so my data is going to be a little bit skewed or different from yours. So for me, for the first circle, I filled it with 5 beans. Circle 2, I filled it with 19, 50, 84, and 189. So I'm going to work with my data and you do work with your data. We don't have to have the same numbers. The idea is basically going to be the same, but we might be working with different numbers. That's fine. Okay? So that's the table. Now we have to decide whether which one is going to be our independent and which one is going to be our dependent variable. Now remember, independent means x and dependent means y. Okay? So what do you think depends on the other? Does the diameter depends on the number of beans or the number of beans depend on the diameter? Remember, as the circle gets bigger, we can fill it with more beans. So the diameter is going to be our x and the number of beans is going to be our y. Now our next step is to create a scatter plot. Okay? Now think about it. Do I need the whole coordinate system or I only need the first quadrant? Now since the x and the y are both positive, so it would be helpful to just work with the first quadrant. Okay? Because everything is positive. This is the x, this is the y. Go ahead, pause the video, and remember you need to form a scale on the x-axis and a scale on the y-axis. Plot the points that you have in your table. Remember, for me, for example, the first point is going to be 1, 5, the second is going to be 3, 19, and so on. So pause the video, take 5 minutes to plot these points. Remember to work as a team. So you'd finish on time and all of you will have something to add to the work that you're doing. So pause the video and do the work. Now, this is what I got. Now, as you can see, on the x-axis, every 3 squares I counted by 1, okay? And since the highest number I have is a 9, so I got to an 8, and the 9 is going to be off the graph. That was fine for me. Now, as for the y-axis, I counted by 10, as you can see, okay? And I plotted each point, okay? And when I connected them, it gave me like not a straight line, a bent line, okay? Now remember, we're gonna learn different forms, different functions. We're gonna learn exponential, logarithmic, quadratic, linear, and every single time you're gonna be asked to get the regression equation, and they might not tell you what type of function it is. So we always have to have a second method, which is basically the calculator, to help us decide what type of function it is. But now since we only learned the linear and the quadratic, we're going to be comparing them and deciding using the calculator what type of regression it is, okay? So let's see how we can do that. Now from looking at the table, from looking at the graph, I can tell that this is not a straight line, it's a quadratic function, okay? But we also need a second method. What if the graph is not very clear? So we need something more dependent, more, let's say something we can we can trust, which is the calculator to give us the equation, okay? Now, how can we do that? Using our calculator, we're gonna find the regression equation. You see that? Regression equation. They didn't tell us whether it's a quadratic regression or a linear regression. We have to find that out. Now we need to try both of them then. And we have to turn the diagnostics on, and we need to record something called the R-square value, okay? So what does that mean? So let's go to our calculator. And remember, do you remember how to record the data on the calculator? You go to Stat, press Enter, okay? Now pause the video and take your time to plug in. Remember, the x values go in L1 and the y values go in L2. So go ahead and do that. Please follow along on your calculator. Now I'm going to move on to L2 and input the numbers. Okay. Now remember, I don't know whether it's linear or quadratic, so, and they're asking me to turn the diagnostics on. Now how can I do that? Now if you go to your calculator steps, okay, there's a place over here where it tells you how you can turn the diagnostic on, so make sure that you highlight that part and let's do it together. Basically it's telling me to go to second 0, which is the catalog, and we have to go all the way down to D where I need, because I need the diagnostic on. So press D and it will directly jump to D, and I need to go down until I get to something called diagnostic on. Because probably it's off. Okay, there you go, diagnostic on. Press enter again until you see the word done. It means your diagnostic is on now. Now, let's go to stat again. And now, remember when you want to find the linear regression, what do? We move on to calc, and then we press number 4, and this will give us our linear regression, okay? So keep pressing enter until you get to the equation. Now, as you can see, before, I used to only be able to see the equation in A and B. Now I see something called R squared and R. And the reason why I see R squared now is because I turned the diagnostic on. So why is R squared important? We're going to see that in a minute, okay? So let's go to our notes and let's record the data that we got. So our equation, let's round to the nearest hundred here, just for the sake of the problem. So I'm gonna say 22.96x minus 39.41, and as for the R squared, I'm also gonna round to the nearest hundred, and I got a 0.94. And again, we're gonna discuss in a minute what does the R squared mean. Now, remember, I don't know, it could be linear, it could be quadratic. Let's say that the graph was not very clear. So I'm gonna do the same steps again. I'm gonna go to stat, calc, but this time I'm gonna find the quadratic regression, which is number 5. Okay, and I'm going to press enter until I get to the equation. As you can see, I was able to see the quadratic equation with ABC, and I was able to see R squared as well. So let's record the information, and remember, let's just round for the nearest hundredth now. So I got 2.12x squared plus 1.062x. I don't know why I put 2. Forget about that. Let's remove that too. 1.06x. And then plus 0.47. Okay? Now, as for the R squared, I found it to be 0.99, almost a 1, right? Because if you round to the nearest hundredth, it will be a 1, since the third number over here is a 9. Now, let's look at the data that we just gathered. Okay, which one is nearer to 1? Is this R squared closer to 1, or this R squared closer to 1? Okay, this R squared is closer to 1. Then the best representation for this data is quadratic. So that's why R squared is important. It tells me which one is a better fit for my data. So based on R squared value, which is a better fit? The quadratic. Okay, because the R squared is closer to 1. And another thing you can say, because the graph, it looks more like a U shape, it's bent, it's not a line. But remember, sometimes when I give you data, you might not have enough time to plot it. Maybe the easiest thing you can do is to find the equation and look at R squared to decide whether it's quadratic or linear, okay? So that is one way you can decide. Basically, it's two ways. One is the graph and one is the data. This is more reliable, okay? Now, this is for the front page. Now let's move on to the back page of your notes. In here, they're gonna give you certain data, maybe either X or Y, and you need to find what's missing. So let's look at number 7. In number 7, they tell me to predict the diameter. So let's underline that. Of a circle that would hold 50 beans. So what is given in this case? Is X given or is Y given? Let's go back to our table and see. What did we label as Y? The number of beans is going to be my Y, and the diameter is going to be the x. So that's why it's very important from the beginning to decide which is x and which is y. So in this case, they want you to find x when y is 50. How can we do that? There's one way to do that. Basically, let's use the calculator. The reason behind that, since we know that this is a quadratic equation, let's write it down. It's y equals 2.12 x squared plus 1.06x plus 0.47. Now, if y is given, then you need to plug in 50 for y, and then you have an x squared and x to worry about. It's going to be very hard to solve it, so then let's go to our calculator. How can we do that? Now you go to y equals, let me make this smaller so you can better see. Okay, so let me clear that. Go to a larger screen so you can see what I'm typing. So I'm going to go to y1. I'm going to input the data that I just got, which is 2.12x squared. Okay, so in y1 you put the equation that you just found, plus 1.06x plus 0.47. Okay, 0.47. Now I'm going to go to y2 and I'm going to put the value that is given to me, which is in this case a 50. Okay, so on y1 you put the equation, and on y2 you put the number that they gave you, which is 50. And let's graph it. Do you think you're going to see both of them, the blue and the red? Let's see. That's the blue, but you cannot see the red. Why do you think it is so? Because your window, if you go to your window, your y maximum is a 10. It's not showing you the 50 because it's way bigger than the number that you have. So you need to go to y max, which is the upper part of your graph, and put it to be a number greater than 50, which is in this case, let's put 70, 80, whatever you want. So let's graph it now. And now you should be able to see both graphs, which is the equation that you have and the 50, so the red line. And what you really need is the intersection between the two graphs. Now, as you can see here, we have two intersections. But this one will give you an x value. And remember, x stands for diameter in this case. So can diameter be negative? No. So we don't really care about this intersection. We care more about this intersection because it's going to give me a positive x. Do you remember how to find the intersection of two graphs on the calculator? You go to second, trace, then you go to number 5. You move the cursor a little bit to the right because you want the calculator to know that you want this intersection. And you press enter 3 times. So as you can see, it tells you to have 50 beans in a circle, the circle should have a diameter of 4.59, which is 4.6 almost. So let's go back to our notes and let's write that down. For 50 beans, I have to have an x of 4.6 or 4.59. Okay? So 4.6 centimeters to have 50 beans. Okay? Now pause the video and try 100 beans and 1,000 beans on your own. Now, where can you find the calculator steps? Now I want you to go to your notes. Let me make this bigger so you can see it. Now if you lift the paper up, okay, you will see that to find x when y is given, you go to second graph. No, here to given y and you need to find x. You go to y equals, okay, and then you put in y2 the value given to you, which is in this case a 50 or 100 or 1,000. You fix your y minimum or y maximum. Remember that. You go to second trace, number 5, which is intersect, enter 3 times. So that is where you need to look whenever y is given and you need to find x. So the steps are written for you. Please take notes to make this, for this to make more sense to you, okay? So make sure that you highlight that. And this is an example, for example, which is when y is 50 beans, find x, to know what this stands for. Because basically if you look at this calculator steps, you will say maybe it does not make sense. But now when you link it to a question, it will make more sense to you now. Okay? Whoops, I need to charge my iPad. Okay, so now let's move on to the next question. So let me go back to my notes. Now in number 8, they're saying predict the number of beans. So now what do they want? They want y. When the diameter of the circle is 30.5 centimeters. So as you can see in this case, x is given and you need to find y. So there's more than one way to do that. You can go back to your equation and plug in 30.5 for x and solve it. Okay, so you can, this is one way. Okay, I'm going to show you 3 different ways and you choose whatever you want. You can go to like 2.12, open parentheses, for x put 30.5, square, and so on. Okay, until you get and plus 1.06, open parentheses, 30.5, close parentheses, plus 0.47. You can do that. This is one method. Another method is to go to second window. Okay, remember, you can use any method you like. So the second method is to go to second window, which is table set. Now the x is given, so go to independent instead of auto, put it to ask and press enter. After you do that, you go to second graph, which is the table, and as you can see, the table now will be empty. It means you did something that's right. And you put 30.5 and you press enter, and it's going to give you the y value, which is in this case 2004 beans. Now the reason why you see a y2 is because you have a y2 over here. So if it's bothering you, you can just clear it, go back to second table, and as you can see, 2004 is the number of beans. So let's repeat the steps. It's second, table set, go to independent, move it to ask, press enter, second graph, the table will be empty, input the value that you want, and the y then will be automatically calculated for you. So now for a circle of diameter 30.5, you will have 2004 beans. So this is another method. A third method is to go to second trace. And now instead of pressing 5, you press 1 because the x value is given to you. So second trace 1. Okay? Now once you do that, it's going to be graphed. Let me make this smaller so you can see it better. And then they tell you x equals what? And you need to tell them that the x is going to be 30.5. And you're going to press enter and it should give you a y value. Okay? Do you think it will give you a y value? Let's see. Invalid. Why do you think this happened? The same idea. Remember when we tried to graph and we were not able to see the red line? It's because the window was not fixed. Now, as you can see, my x maximum is a 10, and I'm inputting an x value of a 30.5. So that's why the calculator did not make sense out of that. So put x maximum to a higher number than 30.5, maybe a 50. Okay, whatever number that's 30.5. Now do the steps again. Second, trace, 1. It's going to give you x equals what in a minute. Come on, okay, there you go. 30.5, press enter, and there you go. It's going to give you the same value, which is 2004. So these are 3 ways, and you can use any method that you like. Now, where can you find these steps written? I think I only wrote down one step, one method, but it's up to you what you use. Okay, so given x, find y, so that's the part that you need to look at. So as you can see, I only written, okay, yeah, second trace 1 value, this one, but remember there are more than, okay, you may need to get the iPad to know what I'm talking about. Okay, so second trace 1 value and so on. So this is the part I've only written one method, but you can watch the video again and do whatever method you like. Okay, so let's go back to our notes. Okay, now we've done number 9 and we found that we need 2004 beans. Now let's move on to number 9. What is a reasonable domain and range for this? Now remember, domains stand for x, and in this case, the x is diameter. So can the diameter be negative? No. Can it be 0? Yeah. The circle could be just a point. There could be no circle. So I'm going to say that my domain is going to start from 0 and go up to where? Now, no matter what number I give you, somebody can come up with a bigger number. So I'm going to say infinity. It can go from 0 to infinity. And it's going to be a huge circle. And the range stands for number of beans. Again, number of beans cannot be negative, so I'm going to say that the range is going to be starting from 0. I can have a circle with 0 diameter, so it will have no beans in it, so 0 beans. And again, as the circle is getting bigger and bigger, we're going to have more and more beans, so I'm going to say up to infinity. So that's a reasonable domain and range. Now, we've reached the end of the notes. Remember, there's a lot of calculus steps here to remember. So if you need to watch the video again, please do. I'm going to be ready on Monday to answer all of your questions, so please make sure that you do the practice sheet at home. Please put the beans back into the bags because my other classes will be using them. Thank you for trying your best, and I'll be seeing you on Monday.